Welcome to my video on what are rational and irrational numbers. Now, some of you may have heard or come across these terms already. If you're studying A-levels, then you may hear these terms again when studying certain topics like surds. Although it's not essential to know what these mean, it's still useful nevertheless. So let's first start by defining what they are, and then I'll show some examples. Okay, so a rational number is that number which can be expressed as a fraction where both the numerator and denominator are integers or whole numbers. So the number 7, for example, can be expressed as 7 over 1. And as you can see, this is a fraction where both the top and bottom are integers. Therefore, this means that 7 is a rational number. Okay, now an irrational number, however, is simply the opposite of a rational number. What this means is that it cannot be expressed as a fraction where both the numerator and denominator are integers. Okay, now I'll show an example of this as well as many more towards the end of the video, but for now let's look at some more examples of rational numbers. Okay, let's explore why all of these numbers are rational. Remember, our aim is to express all of these as whole number fractions. So the number 4 can be expressed as 4 over 1. This is a fraction where both the numerator and denominator are whole numbers, which means 4 is rational. Same thing with 30. 30 can be expressed as 30 over 1. So again, 30 is rational. Minus 7, this can be expressed as minus 7 over 1. Now, despite the 7 being a negative, it is still an integer nevertheless, which means that minus 7 is also rational. 0.5, so we have a decimal here, but this can still be expressed as a fraction. Hopefully you should realize that this is the equivalent of 1/2, which means that 0.5 is also rational. 6.5, this can be expressed as 13 over 2. So 6.5 is rational. 15 over 237. Well, this is definitely rational because it is already in the form of a fraction where both the numerator and denominator are whole numbers. So no problem here. Minus 4.25, this is the equivalent of minus 17 over 4. So this is also rational. And finally, 0.34527. So a slightly strange one here, but you should realize that this can be expressed as 34,527 over 100,000. Okay, despite these being large numbers, they are still integers, which means that 0.34527 is rational. Okay, so that's our examples here covered. Hopefully this was nothing too difficult. The aim is to just be able to convert these numbers into fractions, and if that can be done, then it means the number is rational. Right, let's now look at some other examples. Okay, so here we have some rational and irrational numbers. So let's look at these and try and figure out why they are different. What you should notice is that each of these examples are numbers containing a non-terminating or never-ending decimal. The decimals go on and on. However, there is a significant difference between the rational and irrational ones. In these examples here, there is a repeating pattern. In this example here, 3 is being repeated, and in this example here, 1 3, 1 3, 1 3 is being constantly repeated. Whereas in these examples, there is no repeating pattern whatsoever. So, when we have decimal numbers that contain a repeating pattern, we call them recurring decimals. And what you should know is that recurring decimals can be expressed as fractions. So this one here, which is 0.3 recurring, can actually be expressed as 1/3, which many of you may have already noticed. So therefore, this is rational. As for this more difficult one here, 5.2 with the 1 3 recurring, this can be expressed as 5161 over 990. So even this is rational. Okay, so I'll repeat. All recurring decimals can be converted into fractions and are hence rational. As for these numbers here, they are non-terminating decimals without a repeating pattern. Hence expressing these as fractions is impossible. And which is why these are irrational. Okay, now before we finish up, let me just quickly show you some more examples of irrational numbers. Okay, so we have the square root of 5, the cosine of 10, and pi. Now I've used my calculator to evaluate these, and what we see is the same thing as these examples here. All of these evaluate to non-terminating decimals that do not contain any sort of pattern. That means converting these into whole number fractions is not possible, and which is why these are all irrational. Okay, and that's it for this video. Remember, as long as the number you are looking at doesn't look something like one of these numbers, then it means the number is rational. Otherwise, if it does, then it's irrational. And that pretty much covers all you need to know about identifying rational and irrational numbers. I hope that was all clearly explained. Thank you very much for watching.